Hello, my name is Eric Grant, and this is my ENME 351 Lab 4. Firstly, I'm going to present my code, in which case you can see right here. Here I have the variable p, which is just a change upon the 1023 value. And then here you have the value of f. F equals 0 right now, but that's for the frequency that's going to be changed. This is the serial to output the stuff. This is the end scope reading, and this is the potentiometer reading. And this is an else if loop. If the potentiometer is up here, and else if here is it'll switch here. This is just a switch between the values as you turn the potentiometer. Here is the delta that you'll need, which is 1,000 divided by f, and this is the end scope value being put out to processing so that it can be read on the oscilloscope, and this is the delay given in the delta. For like all my signals and everything, is a closer view. This is the 75 signals. This is my 100. And now these are a bit lower resolution because I use the delay method instead of using a timer like they said in the lab. So these results aren't exactly the most accurate, and also I had to kind of guesstimate the numbers for the frequency. Right here you can see the table I use for figuring out the alias frequencies. Yeah, so my general method was just like going in between, going a bit further in between to figure out what was what. And, yeah, my folding diagram. And this is my table. So on this table you can see that the parts with check marks on it are the parts that had no aliasing because of the fact they were double or more than the sampling frequency here, as you can see right now. This one's kind of weird though because it was kind of under, but it still ended up sampling. I figured it was just an estimation type of thing, so I felt like it still sort of worked. Overall, I wasn't like the theoretical didn't really match up with the experimental, but that has to be due to the noise in the system as well. You have to account for that. Okay, there's the last part of my video, in which case I'm going to go over my triangular wave and my square wave. Here you can see my circuit. It's probably hard to see because of the lights getting in the way. I apologize for that, but it's set up correctly. And here is my triangular wave as well as my square wave. Now, the main thing that occurs with these is that because they don't really converge on a singular value, as you can see from these little abruptions right here. They still go on and on and on. They don't directly go to one value. That's because of something called Gibbs theorem, in which case they can't converge because of the discrete values inside of them, and it's going from high to low frequencies so abruptly. Yeah, and that's it. As you can see, oh yeah, as I said before, you can see here, these are much like our spectrum plots, in which case you can see that these would be the different terms that we have for our harmonics. That is it for the video, and have a great day.